Hello, hello, hello. Hello everyone. Welcome to my channel. I'm Subhrajit Sahu, Assistant Professor in Narsimareddy Engineering College. Today, what we are going to discuss in this video means one more new pressure measuring technique, pressure measuring instruments we are going to discuss here in this video. What is that pressure measuring instrument or technique here? Very interesting. That is really that is thermal conductivity gauges, right? Actually, in this temperature measuring instrument, we are taking the help of some electrical components. Without electrical components, we cannot measure by using this kind of measuring instruments. Earlier, the button tube pressure gauge, dead weight, gauge or dead weight tester, bellows, diaphragm, all these are purely mechanical instruments. No electric power is required. But right now, what instruments we are going to discuss, their electric current supply, power supply is must necessary. That's why I told some electrical components will be involved here in this particular measuring instrument to measure the pressures, right? Okay. Anyway, we will discuss everything slowly. So thermal conductivity gauges, right? It is working on which principle? What is the principle working behind it? Let us first see this one. No, thermal conductivity gauges, the name itself indicating what? It is working on the principle of a thermal conductivity. That means here the pressure will be measured, pressure will be measured based on this thermal conductivity, thermal conductivity changes, right? The pressure at a particular place or particular systems, how it will be measured based on the thermal conductivity changes. Okay. So before discussing about this topic, this working principle, constructions, everything, let me tell you what is this meaning of thermal conductivity. I know you know, everybody know this concept. It is not a new one, very easy. Generally, there are three modes of heat transfer, you know: conduction, convection, and radiations, right? And that conduction, convection, radiation, 1 minute. This one, which one? K. It is denoted by this symbol K actually. That thermal conduction or thermal conductivity is denoted by the symbol K actually. What is the unit, sir? You know, heat transfer Q equal to minus K A dt by dx. From this, if I'll simplify this one, I will get the K value or K unit. I will get joule per or kilojoule per meter Kelvin. Like this unit I'm going to get, right? Okay. Okay. So here it is the unit of the thermal conductivity. K equal to K is in joule per meter Kelvin. Okay. Sir, how this thermal conductivity is importance or giving importance in the pressure measurement? Let us see. Sir, suppose I will give some certain examples here. Suppose you consider mm, this is a tube, right? A tube you consider, hollow tubes. Okay, now this two end is insulated. This two end is insulated. That means heat cannot transfer. This two end insulated. This end not insulated, and this end is not insulated, right? And inside some gases are filled. Some gases are filled, right? Gas are filled. Now this side I will expose to a hot region, right? Sir, what I took a tubes. The lengthwise, the longitudinal sides is fully insulated, so no heat will be transferred. Only this circumferential sides, it is not insulated. That means heat can be transferred. Now in between I filled with gas, right? Now when this end will be exposed to hot region, then automatically this gas particle will be receive heat first. This surface will be heated first, then gas particle will be received from this surface, then heat will be transformed from one gas particle to another gas particle, then another gas particle, then another gas particle, like this. Finally the heat will be reached at this wall, right, at this wall. Okay, so how the heat is flow, sir? It is flow because of this molecule they are passing the heat from one molecule to another molecule, one molecule to another molecule, one molecule to another molecule, and finally at this end also I can able to fill the gas. Now what I will do, sir, once again I will take one more tubes, but this time length is less. Okay, length is less. Same situation, insulation, this time this side insulations. And here again same gas, same quantity. How much quantity here in this pipe? Same quantity I filled here. Sir, what is the difference? The difference is here volume is more, here volume is less, and gas is compressible. It can be adjusted at any volume. A very less volume also same quantity we can keep. In a very large volume also same quantity we can keep. So this time I reduce the volume. Okay, I reduce the volume. Now again same I expose this one hot region. Okay, hot region. Now what will be happen, sir? This surface first will be heated, then heat will be transferred to this molecule, then this molecule, this molecule, this molecule, this molecule, and finally I will get heat here. Now if I'll compare this one and this one, in which case the heat transfer will take first, sir? First. Okay, quickly this one. Why? Because since the volume of the pipe is reduces, so gas is compressed here. Since gas is compressed, molecule gap is reduced in comparison to this one. Molecule gap is reduced, and this molecule gap in a technical term is there, free min path. Okay, so if we compare this system and this system, in this system free min path between molecules is less, whereas here it is more. That's why here molecule to molecule heat transfer quickly done comparison to this one. That's why it will take less time, right? Less time to transfer heat from this end to this end, right? Now same way I am taking one more tubes. This time less length, again less length, again less length, again less length this time, and same two sides are insulated. Okay, again gas molecules are there, again gas molecules are there. Again I expose this one to hot region. Okay, then what will be happen, sir? Again what will be happen? The heat will be transferred from this molecule, then this molecule, finally this will be. Now if I'll compare these three things, sir, if which one will take very less time to transfer the heat? Sir, this one, obviously this one, okay, why? Because by reducing the volume, by decreasing the volume, what I'm doing, the molecule gap, which is nothing but called as free min path, is reducing. Once the free min path will be reduces, then what will be happen? If the free min path will be reduces, then molecule transfer the heat very effectively. That's why this end will be get heated very quickly as comparison to first one and second one, right? Okay, so this is the concept I told, how the heat will be transferred. Now observe the important point here. What is the important point? Here volume is more, here volume is a little bit less, and here volume is further less. Again, it is less, right? If I'll compare this one, in which case pressure is more? In this case, pressure is more. Okay. In this case, pressure is more. Comparison to this one and this one, right? Okay. So pressure is more, and here, since the heat transfer is done very quickly, can I say the thermal conductivity of this system K is more comparison to this one and this one. Why? Because thermal conductivity this system is more. Why? Because heat transfer done very effectively and very fast, quickly comparison to this one. So thermal conductivity is nothing but it is a property. It is a property which measure the heat transfer. So in this case, the nature of heat transfer it is measured. So in this case, the heat transfer done very fast. So thermal conductivity of this particular system is more, and pressure also observe. Pressure, since volume is less, pressure is more, because there is a relation. Pressure is inversely proportional to volume. So volume less means pressure more. So pressure more, that means volume less means pressure more, and K also, thermal conductivity also more. P more, K also more. But in this case, P comparison to this one, P is less, and thermal conductivity also comparison to the third one also less. That means I got one relation. Somewhere P and K there is some relation. What is the relation, sir? Proportional relations. If pressure more, thermal conductivity is more. That means heat transfer heat transfer will be done very fast, right? Okay. One more important relations I will tell. Then I will tell the topic, right? Observe carefully. What is the next one, sir? Next one is, sir, what about the density? Rho. One more important parameter, density. Okay. Now see, in this case, volume is more. In this case, volume is less. We know rho equal to mass by volume. Right? If the volume is more, then density is less. If the volume is less, then density is more. If I'll compare the one system and three system, which having density more, sir? This is having volume less. Volume less means density more, right? So in this particular system, what I got, sir? Pressure is more, density is more, and thermal conductivity is also more, right? So in this explanations, what conclusion I done, sir? The system which is having pressure more, that having density more, that having thermal conductivity also more. If thermal conductivity also more, then heat transfer one system to another system is more. If heat transfer is more, then the system will be cool very fast. If the pressure is less, then density also less, K is less, heat transfer also it will take more times, so it will cool late, right? This is the two important derivation, important concept I got from this explanations, right? And my thermal conductivity gauges is working on this principle only, because I'm going to measure pressure. Now see, in this expression there is some relation between pressure and thermal conductivity, is there or not? Yes. By applying this principle, I can able to measure the pressure of a system. But basically this thermal conductivity gauges is used to measure which pressure, vacuum pressures. That means low pressure to moderate pressures, not high pressure, low pressure to moderate pressures. Why not high pressure? I will tell some limitations, some disadvantages is there. But generally it is used to vacuum pressure measurement, negative pressure measurements. Successfully we can able to measure 0.5 torr to 1 into 10 to the power minus 4 torr. Okay. This much range pressure effectively we can measure by this thermal conductivity gauge. This thermal conductivity gauge, several types are there. Today I am going to discuss about which gauge? Pirani gauge. Okay, Pirani gauge. Pirani gauge is my today topic. You know, Pirani gauge. It is the name is given. The name is here based on the person named as Stefan Pirani. Okay, Stefano Pirani, who is the Germany physicians who discovered this Pirani gauge concept based on this thermal conductivity in the year of 1906, right? So we are going to discuss about this Pirani gauge, which is working on the principle of thermal conductivity. I hope you can understand what is the thermal conductivity here, right? Observe carefully. Now this one. So this is one diagram. This is one diagram. So two way we can do in the there are three methods. By these 3 methods we can do the pressure measurements by using this Pirani gauge. 3 methods. I will tell the both methods here, don't worry. Now this is my first one. This is the Pirani gauge. Sir, I told some electrical equipment is required. So here Wheatstone bridge circuit is used here. Wheatstone bridge circuit is used, and the Wheatstone bridge circuit is supplied with some voltage. Okay, some voltage supplied, and out of this 4, here this one is the sensing element, pressure sensing elements, right? So this is the resistor. Okay, na, sensing resistor or sensing element. It is made up of, okay, na, platinum or tungsten or nickel. Okay, any material we can use. Okay, na, because these materials having good thermal conductivity. These materials having good thermal conductivity we use. Now, sir, how it is, and this is the construction, right? You can write by looking this figure. Suppose this resistor is R1, okay, R2, R3. Anyway, and this is the galvanometers, right? This one is the galvanometer, GV galvanometers. Okay. Now what I will do? What is the workings are very simple. Now suppose this is the pipeline where some gases are flowing inside the pipeline. Some gases are flowing, right? Now I want to measure the pressure of this gas, what is flowing inside this pipeline. Then what I will do? I have to connect this pipeline with this system. Okay, with this system I have to connect. Once I will connect this system, what will be happen, sir? The gas molecule, okay, the gas molecule will start entering to this, okay, entering to this gauge cell. This one is called gauge tube, right? This is called gauge tube or sensor tube, GAUG, gauge tube. It will enter to the gauge tube, right? Now I have supplied a voltage. I have supplied a voltage to the circuit. So once I will supply the voltage to the circuit, what will be happen, sir? Okay, first suppose the valve is closed. Suppose the valve is closed, there is no flow of this gas particles. Now I supply the voltage. What will be happen, sir? If I supply the voltage, current will flow. This wire get heated first. This wire will be get heated. We know na, because whenever the current will be flow, the resistance will be get heated. Okay, just like iron, room heaters, right? Some heating equipment is there na? So whenever you are giving the current, the coil will be there, that current will be get heated. So same way I'll give the current here it is heated. Okay, it is heated. It is heated means some temperature generate here. Some temperature will be generated here. Now what I have done, sir, I have done the connection to this chamber, to this gas tube with this pipeline. Okay, na? With this pipeline I done the connections. Okay. Now the gas will be starts to flow. Suppose when the gas will be starts to flow, I don't know the pressures. I don't know how much the pressures. Suppose very high pressures. High pressure is there. If pressure is more, what will be happen, sir? I told if pressure is more, density also more. If density more, thermal conductivity also more. Okay, na? Thermal conductivity also more means whatever the heat at this resistance surface, that will be passed to this gas particles, right? This gas particles that will be passed. That means the gas molecule will be get heated because pressure suppose more. Okay, na? Then the gas particles will be carry the heat from this filament. This is called this sensing elements or filament. Once the gas particles will be carry the sensing elements heat from this filament, what will happen? The filament temperature will be reduced. Filament temperature will be reduced. If the temperature will be reduced, then resistance of the circuit will become imbalance. The resistance of this Wheatstone bar, because already we have discussed the resistance is proportional to temperature. If temperature changes, resistance will be changes. Now, how the temperature decreases, sir? Because these gas particles carried out the heat from this filament sensing element. That's why temperature of this filament is reduces. If temperature of the filament will be reduces, then what happened to the resistance? Resistance also reduces. If resistance reduces, then the circuit become imbalance. Okay, na? The circuit become imbalance. If the circuit become imbalance, here the galvanometer from null position, it will start showing some reading here. Okay, it will deflect. It will deflect and it will start show the reading. Okay. So how much the galvanometer deflected? How much the galvanometer deflected? What is the cause, sir? Cause is because of resistance changes. Okay, na? Why the galvanometer deflect? Cause is because of resistance changes. Sir, why the resistance changes? Because of temperature changes. Sir, why the temperature changes? Because of the thermal conductivity. Because of this gas thermal conductivity, the heat will be transferred. Sir, because of this, sir, this thermal conductivity, how it is came? Because of this pressure only. If pressure more, thermal conductivity more, then temperature will be reduces, then resistance also reduces, then resistance if reduces, then galvanometer will be shown the reading. That means ultimately this galvanometer reading, can I calibrate it to the pressure reading? Yes, I can calibrate. I can calibrate the pressure reading. In this way, we can measure the pressures. We can measure the pressure by using which one? Pirani gauge. In this case, sir, what is the assumption, sir? Voltage is constant. I supplied a constant voltage to the circuit. I supplied the constant voltage to the circuit and I allowed to change in resistance. Sir, why the resistance changes? Because of temperature changes. Why the temperature changes? Because of heat transfer K. Okay, now because of conductivity, heat transfer done. And how this conductivity will be? There is a relation between conductivity and pressure. If pressure is more, conductivity is more. Suppose now the pressure is low. Okay, na pressure is low. Pressure is low means conductivity of the gas is what? Low or not? Low. That means less amount of heat will be carried by the gas. If less amount of heat will be carried, then again temperature will be increase. Again temperature will increase. If temperature again changes, again galvanometer this circuit will be become imbalance. Again galvanometer will be show the reading. Like this, it is going to be one. Very interesting, right? This is one method. What is the method, sir? Voltage is constant and I allow and temperature here changes. Okay, voltage constant, temperature changes. This is one method by using I measure. Second method is what? In this method, I will keep temperature constant. Voltage I will change. Voltage will be changes. Now observe. Very simple. Here, little bit construction is different. Reference tube and gauge tubes. It's there. Okay, reference tube and gauge tubes. Both the wire are platinum wire. Platinum or nickel, same. Platinum or nickel or tungsten wire, right? Now, here is the power supply. Okay, some voltage I have given. Some voltage I have given, and I know when the voltage or current will be flow in the circuit, what will be happen, sir? The temperature will be changes. I will fix this gauge tube sensing element, this filament and this reference tube filament temperature to 50 degrees, suppose. How much degree? I'm keeping the temperature fix here. Okay, temperature is constant. So I will give the voltage in this circuit such that the temperature will be rise. By increasing the voltage, temperature will be rise, and I will fix the temperature as 50 degrees Celsius. Okay, at what voltage the temperature become 50 degrees Celsius, that voltage I supplied here. Now I keep the temperature fixed at 50 degrees Celsius, right? Both reference tube and gauge tubes. Okay. Now see. Now I will collect. This is actually the instrument, right? This is the instrument. This is the internal circuit of this instrument, right? Internal circuit. Now I will connect this system, this measuring instrument, to the pipe where gas is flowing. Pressure has to be measured, right? I will connect. Now the temperature is 50 degrees Celsius. Now suppose the pressure is high in this pipeline. So high pressure gas will be entered to this gauge tube. Okay, enter to the gauge tube. And high pressure more means already you have discussed density is more and thermal conductivity is more. And thermal conductivity is more means what will be happen, you know? Temperature, the heat transfer become more. Heat transfer become more. Okay, na? Heat transfer become more here. If heat transfer become more here, then what will be happen? This filament, platinum filament will cool very fast. That means temperature of this filament will be reduces. Okay, na? If the temperature will be reduces, what I will do, I will supply the voltage again, so that the temperature become 50 degrees Celsius. Okay, na? Sir, why the temperature reduces? Because I connect the circuit to the region or to the system where pressure has to be measured. Suppose the pressure is very high. So pressure high means thermal conductivity, density of this gas will be very high. If thermal conductivity is high, the heat transfer rate is more, and temperature will be down. Temperature will be falls very fast. That means platinum filament will be cool. Then what I will do, if it is temperature reduces, then again I will supply the voltage here in the circuit. I will increase the voltage so that temperature again reached 50 degrees Celsius. Right? Temperature again reached 50 degrees Celsius. Now, how much voltage I extra give? Delta V? How much voltage changes I have done so that again I reach 50 degrees Celsius? Okay, na? Okay, na? 50 degrees Celsius. That can be used to measure the pressure here. In the previous one, I measure the pressure because of resistance changes. Now I'm going to measure the pressure because of this voltage changes, right? Voltage changes. Okay, na? So, sir, how the voltage? Sir, why the voltage changes? Because pressure changes here, thermal conductivity changes here, so temperature fall down. So if temperature fall down, I give the voltage to make it again 50 degrees Celsius, right? I give the voltage, I increase the voltage again to make it 50 degrees Celsius. 50 degrees Celsius, that means temperature constant. So how much voltage I give to make it 50 degree because of this pressure changes or not? Because of this pressure changes only, these many things is happen. Pressure changes, thermal conductivity changes, temperature reduces because of this pressure only. So this change in voltage now become the measure of pressures by using a suitable calibrated pressure measuring scale, right? So this is the two methods I told. One is what? One is One is voltage fix, resistance changes or temperature changes. Okay, resistance or temperature changes. Another method is what? Another method is temperature is fixed. Okay, temperature is fixed, voltage changes. Okay, by these two methods we can construct what? Pirani pressure gauge, thermal conductivity pressure gauge. Sir, observe here. What is the advantages and applications? It is used for vacuum pressure. I told already in the beginning what is the range of pressure it can measure, right? So these are inexpensive, less cost. Rugged means robust, very strong, can be read remotely. Okay, na pressure measurement, it result at low pressures. Okay, the gauze is preferred over the thermocouple gauze, which is another type we are going to discuss. Thermocouple gauze, conductivity gauze is there, right? Thermal conductivity gauze is there, another type we are going to discuss, right? It is faster, it is preferred because it is 10 times faster and wider range pressure can be measured. These are the several advantages and disadvantages. What is the disadvantage? Frequently calibration is required because low pressure, very low pressures like this, pressure range will be changed, so frequently calibration will be required. And accuracy below 10 to the power minus 4, okay, 10 to the minus 4, there is the accuracy issue will come. I told it cannot be used for very high pressure and very low pressure also. So these are the several applications, disadvantages, advantages of this, which thermal conductivity causes, that means Pirani gauges, right? I hope this concept is understand to you. You try to write down the note, everything I have written, only the matter of constructions and working and principles. So you may refer any internet sites to complete the notes. So next video I will discuss some new topic. So till then, take care and bye.